Hello everyone, and welcome back to Math 11. So today I wanted to start Chapter 2, Section 2.1. Now before I begin with the notes, I wanted to show you again where you can find them. So if you go to Teams and you click on General, and then go to the top menu and click on Class Notes, you're going to find the notebook. Now this is the same notebook I used in the class before. So if you click here, and you click on Chapter 2, it will load the sections from Chapter 2. So we're going to start with Section 2.1. If you right-click on the file here that you see, you can save it as, and then you can print it if you want a hard copy. Now you can also open this in the browser, or you can open this in the app if you downloaded the OneNote app. Now I'm going to open this in the app because it's more versatile than the Teams version here or the browser version. But if you just want to view them, then you can just look through the notes. So let's take a look at Section 2.1. So, exploring parallel lines. So before we do any sort of questions or examples, let's take a look at some definition. Now all these definitions are also in the online textbook. So if you go to the Nelson website, which I already posted the link for, you can also listen to the definitions if you want. So the first definition is transversal. So what's a transversal? It's a line that will cross or intersect two or more other lines at distinct points. So here we have three lines shown. Now let's call this my line 1, line 2. So these are L1, L2. And the third line crosses them at two distinct points, here and there. So let's call this my transversal 1, or T1, because you can have more than one transversal line. So in this case, these two lines are not parallel, but if they are parallel, they're going to have some arrowheads showing that the two lines are running parallel to each other, just like the tracks of a train. So if you see this symbol, that means the lines are parallel. Okay? Now there's a couple of symbols that we use for this instead of writing this stuff in words. If you have two lines like this, it means they're parallel. Parallel lines. If you have upside down T, this means that the lines are perpendicular. So perpendicular means 90 degrees. Okay? So for example, instead of writing the lines are parallel, we can just say or L1 parallel to L2. That would be the same thing. So now that we know what a transversal is and how we can show two parallel lines, let's take a look at one of our definitions here, which is corresponding angles. So here we have a rule that works with this definition. So corresponding angles are non-adjacent angles that are on the same side of transversal. So let's take a look. We had to complete this diagram first to make sense of this. So let's call this my L1, L2, T1. And let's make these lines parallel. So again, without the arrowheads, we can't say for sure that the lines are parallel. Now you can't just assume that they're parallel unless you actually know the values for the angles. Now in this case, this is what we're starting with. I didn't just make them parallel. I want to start with the example where the lines are parallel. So how does this F rule work? So it says here, if two lines are parallel, then the corresponding angles are equal. We call this the F rule. So again, to note, if the lines are not parallel, then this does not work. So corresponding angles are located on the same side of the transversal. For example, here's one angle. And the corresponding angle to this one is going to be right here. So it has to be on the same side of the transversal as well as in the same relative position above L1, and then the other one be about L2. You can also have other transversal corresponding angles on the other side of the transversal. For example, let's say if I have one angle on this side, let me use double line here, the corresponding angle would be there. So this is called the F rule because if you look here, the shape that we make here is kind of looks like an F. So for example, if you look at the first two angles that I showed you, we have the two parallel lines, and the angles are located on top of the L1 and on top of L2. If on the other side, let's say if you want to apply the F rule on the other side, it will kind of look like an F that's being mirrored. So this would be your F looking backwards. So those are the corresponding angles. Now it says here at the bottom, the converse or the opposite is also true. For example, if you know that the corresponding angles are exactly the same, that means the lines are parallel. And we'll see that we can use this rule in the example on the next page. So before the example, let's take a look at two more definitions. So we have interior angles and we have exterior angles. So if we have our transversal, our L1, L2, okay? So interior angles are going to be located between the two lines. So this is going to be angles inside L1 and L2. So let's say if we have angles A, B, C, D, E, F, G, and H, the angles which are on the inside are going to be C, D, E, and F. So these four angles are going to be interior angles. The exterior angles are going to be on the outside. So let's say we do the same thing on this side. A, B, C, D, E, F, G, and H. The exterior ones are going to be on the outside. So for example, angle A, B, G, and H. So angles outside L1 and L2. All right, so now we know three definitions. We know corresponding angles, which is the F rule, interior angles, and exterior angles. So let's use the F rule to actually look at one example here. So here's an example. It says here is the line AB parallel to the line CD. So we're going to use the F rule because we're given two angles here. And if you look at these angles, we're getting the values for them. And if I use my highlighter here, this makes an F, which is mirrored. So we notice that the angles are exactly the same. This forms F shape. So these angles are corresponding angles. And notice there is no arrow tips on the line, so we don't know whether they're parallel yet. But because the F rule works in both directions, if you know the value of the angles, that tells you that the lines have to be parallel if the angles are exactly the same. Now, these two angles are exactly the same, 110 degrees. So, you're going to say, let's label these angles with lowercase letters here, A, B, C, D, E, F, G, and H. We see that angle A is the same as angle E in this case. And because of this, because of F rule, we know that these two are corresponding angles, and therefore the lines have to be parallel. The lines AB and CD are parallel. Okay? All right. Now, there's one more thing I want to mention here, and is notation. So for the notation, notice here we have uppercase letters and lowercase letters. So in this chapter, the uppercase letters represent a few different things. So if I have so let's make a note here, note on notation. If you see lowercase letters, okay, these will represent angles. For example, you can say angle A is 110 degrees. Now you can use the angle symbol, which is this little kind of like an arrowhead, or you don't have to use it. For example, you could just use the letter A, 110 degrees. But for the capital letters, so the uppercase letters, there's different combinations which mean different things. So for the uppercase letters, we have a few different options. Most of this times you're going to use either 1, 2, 3, perhaps 4 uppercase letters. So if you have one single letter, one letter, which is uppercase, for example, letter A, this is a point. So this represents a point. Okay? If you have two letters, which are uppercase, example AB, this represents a line from point A to point B. If you have three letters, which are uppercase, and I'm going to have two examples in this case. Let's say I have something like this, little angle symbol, A, B, C. This represents angle ABC. But if I have a little triangle next to it, this represents a triangle. Okay? So, what does this mean? If you have something like this, we have angle A, B, C, D, E, F, G, and H. So you can have notation like that, and again, lowercase letters means angles, but sometimes the diagrams are too complicated to have a bunch of lowercase letters. So in the textbook, a lot of times you're only going to see uppercase letters only, which are going to represent points. So I could also show the same kind of scenario using 1, 2, 3, 6 points. So I can call this my point A, this point B, C, D, uppercase E, and point F. So in this case, for example, if I wanted to represent the angle A, I can say, well, angle A, or I can say, I guess we need to add a couple more points here. F, G, and H. For example, if I'm talking about angle A, I can use 3 uppercase letters and say, okay, this is the same as the angle ABG. Okay? If I wanted to talk about angle C, I can use 3 uppercase letters, so 3 points, and say this is the angle ABE. So notice here, because point B is right in the middle, you can't just say angle B, uppercase B, because you don't know which of these 4 I'm talking about. Am I talking about lowercase a, lowercase b, lowercase d, lowercase c? But because we can use points, we're going to need 3 of them to represent the angle. So let's do one example down here. For example, let's say if I'm talking about the angle F, lowercase f, this is the same as the angle BEF. Or I could have used, for example, point G. I could also said this is the same angle as GEF. Okay, so notice the middle letter is the one that tells you where the apex is. So that's all I wanted to do for today. What I need you to do at home is to look through the video, read this section 2.1 in your textbook, and then do the practice questions, which are again assigned. And you can see the questions assigned for section 2 and the course outline. So for example, section 2, read page 70 to 71, do number 2, 4, and 5. Okay, so again, you can see this in the course information tab, or if you go to Teams and you click on here, course info, and once this loads, click on it, and again, will appear at the end here. So chapter 2, right here. So again, pages 70 to 71, and do questions 2, 4, and 5. All right, that's all.